In this video, we are going to answer the homework question. We start from question number 3, part 3. Fe gives you Fe3 plus. The question is balancing this half equation, and then we have to identify if the half equation is oxidation or reduction. So let's start from the first one. Fe gives us Fe3 plus. You know that when we want to balance the half equation, first we have to balance the mass. But here we have one iron at the left side and one iron at the right side. So the mass is balanced. We have to go for balancing the charge. At the left side, you don't have any charge. It's neutral, but at the right side, the charge is 3 plus. So as you know, we add the electron to the side which we have extra charge to make it same as the other side. So we need to add 3 electrons to the right side. If we add 3 electrons to the right side, the equation becomes balanced both by mass and their charge. And because the electron appears at the right side, this is oxidation half equation. And another sign for oxidation half equation is that the iron has lost the electron, so its charge has increased. Let's move on to part 5. K gives you the K plus. Again, the mass is balanced. You have one potassium at the left, one potassium at the right, but for balancing the charge, you need to add one electron to the right side. So now the charge is balanced as well, and this is oxidation half equation. Let's move on to the next homework question. F minus gives you F2. In this half equation, you have one fluorine at the left, but two fluorine at the right. So in the first step, we have to put 2 as a coefficient here to make the fluorines equal at the both sides. Now we balance the charge. We have 2 minus charge at the left side. We have 2 fluoride ion. Each one of them is -1. So the total charge at the left side is 2 minus. At the right side, it's neutral. So we add 2 electrons at the right side to balance the charge. So this is another oxidation half equation because electron appears to be at the right side of the half equation. So this one is also oxidation half equation. Okay, so let's move on to the next page. Cu2 plus gives you Cu. Again, we have one copper at the left and one copper atom at the right side. So the mass is balanced, but the charge at the left is 2 plus, at the right side is neutral. So we add the electron to the left side. Always we add the electron to the side which we have extra charge, or the charge is more than the other side. So now this half equation is balanced, and because electrons appears at the left side, this is a reduction half equation. So this one is reduction half equation. Another sign that this is redox half equation is that copper ion converts to the copper atom. It means it has gained 2 electrons. Let's move on to the next question. Sulfur becomes sulfide, S2 minus. You have one sulfur at the left, one sulfur at the right side, so the mass is balanced, but the charge at the left is neutral, at the right side is 2 minus. So you add the electron to the side which has more charge than the other. So you need to add electron to the left side here. We need 2 electrons to make the charge equal same as the other side. And this one is reduction half equation. Okay, so let's move on to next homework question. The next homework question is question number 4, part C. For this question, we have to write two half equations, we need to balance them, and we have to identify which substance is undergone oxidation and which one has undergone reduction. So let's do the homework question. As you can see here, the Fe is converted to the Fe2 plus. Its charge has increased. It means the Fe has lost the electron. So this process is oxidation. And we know that Fe is oxidized. When you identify one of the species, the other species is obvious. So obviously this one is reduced. And we can see here Ag plus converted to the Ag. It means it has gained the electron. So this is the reduction. Let's write the half equations here at the bottom. So let's move a little bit. So first I write oxidation half equation. In oxidation half equation, we have Fe and it's converted to Fe2 plus. And for the reduction half equation, in reduction half equation, Ag plus is converted to the Ag. So let's balance each of these half equations. For the first one, you have one iron at the left, one iron at the right, but you need to add two electrons here to make the charge same as the other side. For reduction half equation, we have to add one electron here to make the charge same as the other side, to make the charge neutral. Now we must add these two half equation to get a redox equation, but the problem is the number of the electrons are not equal. So in this case, we have to multiply one or both of them by appropriate number, appropriate coefficients to make the number of the electron equal. If I multiply this one by 2, I will have two electrons same as the oxidation half equation. So I rewrite these half equations here. The oxidation half equation, I write it as it was, plus 2 electrons. But for the reduction half equation, I have to multiply these coefficients by all of the coefficients in the half equation. So when we don't write anything, it means we have 1 or the coefficient is 1. So if we multiply 2 by them, it becomes 2Ag plus 2 electrons gives us 2Ag atom. Now the number of the electrons are equal. We can easily add these two half equation, and the electron in oxidation and reduction cancel out each other. So the final redox equation is Fe plus 2Ag plus gives us Fe2 plus 2Ag. Okay, so let's move on to the next homework. The next homework is part G. Pb2 plus Mg gives you Mg2 plus and Pb. Again, let's identify which species is oxidized and which species is reduced. Pb2 plus is converted to the Pb. Its charge has decreased. It means it has gained the electron. So this is the reduction half equation, and Pb2 plus or lead ion is reduced. And for the magnesium, converted to the magnesium ion Mg2 plus, it means it has lost the electron. So this is oxidation, and we can say the Mg is oxidized. So let's write the half equation for this reaction. First I write oxidation half equation. And then I write reduction half equation. For oxidation half equation, I have, Mg and it's converted to the magnesium ion Mg2 plus. And for reduction half equation, I have lead 2 ion is converted to the lead metal or lead atom. So let's balance each of these half equation. For oxidation half equation, you have one magnesium at the left side and one magnesium at the right side. To make the charge same for the both side, we need to add 2 electrons here. For the reduction half equation, also the number of the lead at the left and right side are equal, so we just need to add 2 electrons to the left side to make the charge same as the other side, to make the charge neutral same as the other side. Now we are allowed to add these two redox equation because the number of the electrons are equal in oxidation and reduction half equation and they cancel out each other. So what remains here is magnesium and lead ion on the left side. They converge to Mg2 plus and lead Pb, sorry, on the other side. Okay, so this one was easy. Let's move on to the next one. Part H. Aluminium is converted to the Al3 plus. Its charge is increased, so it means it has lost the electron. So this is oxidation half equation. And Fe2 plus is converted to the Fe. It means it has gained 2 electrons, so this one is reduction. That's why its charge is decreased. So the aluminum is oxidized and Fe2 plus is reduced. Let's write these two half equations here. So I write oxidation half equation. In oxidation half equation, Al is converted to Al3 plus, and in reduction half equation, Fe2 plus is converted to Fe. Let's balance them. The number of the atoms are equal for the both oxidation and reduction half equation. For oxidation, we have one aluminum at the left, one aluminum at the right, but we need to add 3 electrons to the right side to make the charge equal. And for the reduction half equation, you have one iron at the left, one iron at the right, but you need to add 2 electrons to the left side to make the charge same as the other side. Now we have to add these two half equations, but as you can see, the number of the electrons are not equal, so we have to multiply these equations by appropriate number to make them equal. I can multiply the first one by 2 and the reduction half equation by 3, so the number of the electrons would be equal. I rewrite these equations on the right side. So for oxidation half equation, we will have 2 aluminum. It gives us 2 aluminum ion plus 6 electron because these 2 multiplies by 3 here. And for the reduction half equation, we will have 3 iron, 2 ion plus 6 electrons. It gives us 3 iron atom. Again, these 3 multiplies by coefficient of Fe2 plus, by the coefficient of the electron, and by coefficient of the Fe. Now the number of the electrons becomes equal at the both sides, so we can easily add them. The electrons cancel out each other, and the result is 2 aluminum plus 3 Fe2 plus, and on the product side we have 2 aluminum ion plus 3 iron atom. Okay, let's go to the next homework question. The next question is part B of question number 6. Same thing we have to do here. We have to write the half equation, we have to balance them, and we have to identify which species is oxidized and which species is reduced. Okay, but Here we have magnesium reacts with nitrogen. On the other side, we have ionic compound. So it's not in the ionic format. When you have the ionic compound and you want to write down the reduction and oxidation half equation, it is very helpful to identify the cation and anion that we have there. So the cation here is magnesium, is Mg2 plus, and the anion is nitride, N3 minus. Now we can easily identify what happens to the magnesium. The magnesium has converted to the magnesium ion. It means it has lost 2 electrons. So this is oxidation, and we can say the magnesium is oxidized. And what happened to the nitrogen? The nitrogen is converted to N3 minus. It has gained the electron. So this is reduction. And we can say in this reaction, nitrogen is reduced. So we identified oxidized and reduced species. So we can write the half equations here. So first I write oxidation half equation, and then I write reduction half equation. For oxidation half equation, magnesium atom is converted to Mg2 plus magnesium ion. And for the reduction half equation, nitrogen molecule is converted to nitride, N3 minus. Let's balance each of these half equations. For oxidation half equations, you have one magnesium at the left, one magnesium at the right. The charge at the left side is 0, at the right side is 2 plus, so we add 2 electrons to the right side to make the charge balance. So we always add the electron to the side which we have extra charge. For the reduction half equation, we have 2 nitrogen at the left side, but only 1 nitrogen at the right side. So we need to put 2 as a coefficient for the nitride at the right side to balance the mass of the nitrogen. Now is the time to balance the charge for this reduction half equation. The left side is neutral, but the right side, you have 2 nitride. Each nitride has -3 charge. So the total charge at the right side is 6 minus. If we want to make the charge equal in this reduction half equation, we have to add 6 electrons to the left side. So now the mass is balanced. The mass and charge, both of them are balanced. Okay, now it's the time to add these two half equations, but the number of the electrons are not equal. In oxidation half equation, I only have 2 electrons. In reduction half equation, I have 6 electrons. So I need to make them equal. I can do it by multiplying the oxidation half equation by 3. If I multiply it by 3, the number of the electron becomes 6, same as reduction half equation. But remember that this 3 is multiplied by all of the species that we have in the oxidation half equation. So I rewrite these two half equations on the right side. For oxidation half equations, then I will have 2 magnesium atom. It gives us, 3, we are multiplying by 3 magnesium ion plus 6 electrons. And for reduction half equation, we just write it as it is because we have not multiplied it by any coefficient. So I just rewrite it here. Now I am allowed to add these two half equations. This 6 electron which is lost in oxidation is gained in the reduction half equation, and then they cancel out each other. So now at the left side I have 3 magnesium and 2 nitrogen. So I have 3 Mg plus N2, and on the other side I have 3 Mg2 plus 3 magnesium ion and 2 nitrite ion plus 2 N3 minus. Okay. Let's move on to the next and the last question in the homework, and that is balancing these this equation. Again, on the right side, you have an ionic compound. HF is actually a molecular compound, okay? So you cannot say that we have H plus and F minus, but they share the electrons. So this is actually the covalent compound. But we can assume that the electrons completely transfer from hydrogen to fluorine. So the hydrogen becomes H plus and fluorine becomes F minus. I know that this is not completely true because the HF is not an ionic compound, it's the molecular compound. But we assume it to be an ionic compound. Now we can solve this question. What happens to the H2? H2 is converted to the H plus. It has lost the electrons. So this one is oxidation. And we can say in this reaction, the hydrogen molecule is oxidized. And F2 is converted to the F minus. Okay, it has gained the electron. So this one is reduction, and we can say that the fluorine molecule is reduced. Okay, so for oxidation half equation, I can write H2 is converted to H plus. And for reduction half equation, we can say that F2 is converted to F minus. Now let's balance these two half equations. Let's start from the oxidation. I have two hydrogen atom at the left, only one at the right, so I need to put 2 as a coefficient here to make the same number of the hydrogen at the left and the right side. But now the charge at the left side is 0, at the right side is 2 times plus 1 or 1 plus. Total charge at the right side is 2 plus. If we want to make the charge same at the both sides, we have to add 2 electrons here. Let's go to the reduction half equation. Again, I have 2 fluorine at the left but 1 at the right side, so I need to put 2 as a coefficient here. Now we have same number of the atom at the left and the right side. Charge at the left side is 0 and the right side is 2 times 1 minus, so the total charge at the right side is 2 minus, and I need to add 2 electrons to the left side to make the charge equal. Now I can add these two half equations, and in these two half equations we can see that the number of the electrons in the oxidation and reduction are equal, so we don't need to do anything further. We just add these two electrons cancel out each other, so what remains at the left side is H2 plus F2, and at the right side we will have 2H plus plus 2F minus. Okay, so this was the homework question that we had.